Hi, everybody. Welcome to today's masterclass on project risks. I'm Dan Leamy, consultant here at T, and I'll be taking you through these slides today. So, for the agenda for today's session, I think we're going to start having a bit of a look at some of those common risk areas in retrofit projects. And then once we've thought about those common risk areas, thinking about ways in which we can, or activities or methodologies we can use to kind of identify those risks and make sure we're not kind of leaving any obvious stone unturned. We're going to move on to thinking about risk mitigation and then risk management from a sort of PAS perspective. And then finally, finishing up with kind of the other key elephant in the room, I guess, for these technical risk areas is how that kind of works with resident engagement, for which if you nail, you're going to have a lot more of an easier time dealing with some of those common risk areas. So on to the first section then, understanding common risks in retrofit projects. So one of the very sort of typical areas that you'll find risk and complication in your retrofit projects is structural issues. So you'll turn up at a house thinking you've surveyed and an EPC said this or that needs doing, and then you find something hopefully not as horrendous as something like that in the image with very clearly a very problematic structural crack. But there might be something wrong with the building structure that's going to prevent you from retrofitting it. So that could be, a crack in a wall, maybe not as dramatic as that one, but anything kind of weakens load-bearing elements. Roof damage is a very common one. So you'll go to put some loft insulation in and find there's a bunch of leaky tiles or something, and sort of a damp problem with the joists that you can't just put insulation in there because then it would obviously just get damp and horrible and not work properly and cause further problems. And also things as well like foundation settling, which might be more of an issue in any works that you're doing below damp-proof course, for example, when you're doing your EWI or whatever it might be. So that kind of idea that the property has to be in a sound structural condition before we can retrofit sounds really obvious, because it kind of is, but it's one of those things that you often won't know about until you get there, and then suddenly you're faced with this conundrum, and that's going to throw up additional costs, potentially in terms of remediation works that you will need completing before you can retrofit, and also time delays and contractor delays. Very frustrating. So it's definitely something that we'll need to have an eye on in our retrofit projects as we go about planning, trying to make sure that we can smooth the passage as much as possible so that there isn't those kinds of delays and additional costs wherever possible. Another key area then of risk to consider is around moisture and damp. So that's simply the presence of unwanted water or humidity within the building structure. And there's, you can see what that leads to in some of those pictures there on the slide. So I think that top left one in that little gallery is, I think, rising damp. There's a very moldy ceiling in the middle at the top, and then around the windows there on the right you can see that kind of damp and mold built up, probably from excessive condensation because it's a cold spot on the building wall. But yeah, also things like penetrating damp. So if there's driving rain against an exposed elevation on a cavity wall, for example, and you've got cavity wall insulation in there already, it might sort of have bridged through and let that moisture come into the inner leaf of that cavity wall, and you might end up with something, I don't know, looking maybe vaguely like that bottom left photo or something, where it's come sideways through the wall into the building and causing damp and mold issues. There's a myriad of ways that these issues can present themselves, and sometimes you might think it's one type of damp, or we think this is rising damp, but actually it might turn out that it's just a leaky gutter and the water's running along here and along there, and it's kind of quite confusing sometimes to find the source. But there's as I say, a whole myriad of problems that can arise from unwanted water or humidity within a building, and it's absolutely probably one of the most key areas for retrofit, and particularly, as I'm sure many of you are aware at the minute, it's been in the news quite a lot over the last 2 years or so, due to the terrible effects that it has on people's health. um, and their homes. So ventilation problems, this leads on quite nicely from that actually. So ventilation problems, any issues really relating to inadequate airflow within a building, and that can affect indoor air quality and overall building health. Quite linked, I think, this one to the moisture issues. Um, and examples of this, you might have high humidity inside the building. There might be thermal discomfort because it gets too stuffy, or maybe there's too much airflow and it's too drafty. It could have odor issues. Poor indoor air quality as well if you've got gas burners and stuff on your hob, things like that. So yeah, having there's a lot of problems that you can worsen if you're improving the air tightness and the fabric of the building without addressing these ventilation concerns. That's why any time we talk about fabric first, or addressing retrofit from that kind of perspective, improving the fabric of the building, they go hand in hand with ventilation. It's so key to prevent you from causing more problems than you were fixing. And so yeah, we'll just have a little look now, I think, at some ventilation design on the next slide. So ventilation design, why is it important? Well, we just talked about that, and there's a good example here on this slide of what that might look like. Simplified, of course, but you get the idea that you can see the inflows of air coming through the vents on those bedroom windows, flowing through the house, and it's extracted on the other side of the house through a centralized system, in this case, an extractor fan in the loft space, and then the extracted air leaves the building. Yes. Chilly or a bit too hot, and odor issues as well, if you're not sort of cycling the air through the property in the way that would be best to deal with that. So again, there's a nice little diagram here just to give an example of a sort of a simple sort of walkthrough, or a simple thinking through, I guess, of a complete ventilation system, and some of the things that would need to be considered when designing that. So you'd have to look at the initial starting setup with the ventilation, and think about how the building's currently performing, how what you're doing to it, particularly doing fabric works, might change that, and therefore thinking about what the air tightness then of that building would be afterwards, how you can maintain, or in many cases improve upon the ventilation of that property, so that you avoid all those things we just talked about in the previous slide. And there's a few things to consider there as well around the sort of long-term property objectives, and within the PAS process, that's kind of driven by that medium-term improvement plan usually, but also the occupancy of the property as well. Different people, different households, different lives, different amounts of moist generation resulting from the ways in which people live their lives. So if a house has more people in it than than another house, they're obviously going to generate more moisture through their washing and cooking and cleaning, and simply existing and breathing in that space as well. So very important to consider that, how the building functions in that regard. And then, yeah, lastly, sort of another area as we kind of move away, I suppose, a little bit from that technical building side of things into sort of the ramifications of that, I suppose. Yeah, and another one to consider, occupant health, so that the well-being and the comfort of people living or working in that building. And with regards to those previous things we talked about in terms of the structural integrity of the building, the damp and the mold, the ventilation, and how many people are living in the property, all of those things will factor into the risk factors around things like people who are at risk of developing or already have respiratory problems. You don't want to aggravate that. Exposure to toxins, particularly if you're retrofit, and asbestos, you're often going into older buildings. You don't want to be careful around that kind of thing as well. And simply, the mental well-being of people in those properties, making sure that they're living in, good quality homes. So those are some of the, I suppose, the thought areas, I guess, that we need to be thinking about as we go forward and start planning the delivery of these schemes. There's probably plenty more we can talk to, but I think most of the big issues that people tend to encounter on site will tend to link to one of these things. So next section then, risk identification. So there's a lot of different areas, I suppose, to all that kind of risk stuff. So how can we go about ensuring that we're making sure that we're not missing anything too obvious, or that there's a few sort of techniques you can employ, so even at a desktop level, just to go through and ensure that you're not missing anything, or making sure that you're considering everything that you would need to consider. So having brainstorm team discussions, people from different teams are you getting involved in that is quite important, because people have very different sort of day-to-day areas of work. So one team might have something very much in the forefront of their mind, another team might not. Root cause analysis, so that's particularly, I think, worth doing where where you've had problems before or complaints come up. Having some investigations into why those things have come up previously, and therefore will they come up again, or they're likely to come up again in this project. Doing a SWOT analysis, so that's your strengths, weaknesses, opportunities, threats, sort of within your internal organization, and sort of factors that could impact things externally as well. Expert interviews, so simply talking to people who know a lot about about these particular issues, and there's a variety of places you can get that kind of insight. And then checklist as well, so making using standardized lists to cover common risks, so to make sure we've considered this one, that one, and we have that checklist that we go through anytime we think about planning a particular project on our properties, and maybe we review that checklist after each project as well, just to make sure that if anything new cropped up, that we can bring that forward into our next project as well. So nothing too earth-shattering there, I think, but it's just worth it's worth emphasizing. It's really important to undertake these kinds of activities now, because now is the time where you actually have a chance to do something about these things and mitigate them as well. So as part of those processes and exercises that we can do to identify risks, one of the best places, I think, to get a feel for where we might encounter those risks is also to look at case studies and previous projects, and the various tools and learnings that have come from them. So what I'll do now is I'll just run through point you to a few, I suppose, good case studies or areas or resources, I suppose, to look at, so that you can look into those in further detail if you've got the time, to help you identify where you might encounter similar issues. So the first one on here is program failures. So examples of this include, I think there was one in Glasgow in 2014, so 4 tons of EWI just fell off the top block of top story of a residential tower. Something similar as well happened to a school in Edinburgh in 2014. Grenfell, we know about that. There's a lot of learnings from that, and a very dense report, very extensive. I'm sure, again, most people here are now quite aware of the basic premise of that, and the issues surrounding insulated external cladding, particularly on high-rise blocks. And then, of course, we've got kind of the numerous individual insulation failures over the last 10, 15 years, mostly following poor and inappropriate installation of CWI or EWI. Preston and 2013 Bishwick, obviously kicking off the each home counts review, and therefore PAS 2035 and everything that came from that. But it's also, again, still a big problem. There's been the recent news around the Eco4 scheme, and this is currently suspended installers on that, surrounding concerns around the quality of insulation installation. So there is many years at this point, many years of examples of what not to do and where things go wrong. So it's just worth, thinking about that and thinking which ones might then apply to the kinds of works you're looking for. And so that, hopefully you're not going to make the same obvious errors that have been repeated over the last 10 or 15 years in particular. Another project then, so we're kind of moving into more specific case study examples now, but something that you might want to look at in terms of first one on here, retrofit for the future. So this, I think, was a £17 million Innovate UK program, and they looked at a deep retrofit of 115 houses, I think, across 86 projects. There was 2 years of monitoring and evaluation and reviews to identify, what worked and what didn't. And both of those kind of areas of what went well and what didn't, really, useful in bits of information to know, particularly if you're thinking about maybe not doing deep retrofit right now on SHF Wave 3 or anything like that, but, will be part of hopefully you'll get to that deep retrofit point, over a period of 10, 15, 20 years, whatever it is, where you are, coming back and improving properties further. So having some sort of endpoint examples of that to learn from, worth looking at, particularly if you've got bits of stock that match up very nicely with some of those 115 houses on that particular project. So yeah, retrofit for the future, an interesting one to look at. There's also the GLA's Renew program, although I always read that for some reason as Glare New, but obviously that's not what it is. It's the Greater London Authority's Renew program. So yeah, this was a government supported program within London, and they ended up, I think, coming up with this risk matrix from some familiar names. Lisa Pascali, I think, who's done some work for us actually in terms of these podcasts and masterclasses and stuff. And a couple of other people involved in that. But that was all developed really, I think, to deal with evaluating inherent technical risks and how improvement measures interact with each other and how that may cause more issues as well. And there's something very similar to this actually in PAS 2035. So when we get to the PAS 2035 slides, I'll have a picture of that up on the screen as well. But it's good to get an idea of, again, sort of how much risk is there. But if I'm doing this and this, is that going to be low risk, medium risk, or is there a high risk of something going wrong there? So I need to pay particular attention and really scrutinize and snag the work that's going on there to make sure that everything's as it should be. So yeah, GLA Renew, another one to look at as well. The Centre of Refurbishment Excellence. So this was a project based in Stoke-on-Trent. It was funded by the EU, and they did a lot of work around the process of retrofit, this kind of 4-box process. And I think this is kind of where that retrofit coordinator idea started to come from, with somebody sort of taking some interest or some responsibility across the entire program of work, rather than having sort of people drop in, drop out, and not being aware of what was going on in various parts of the process. And that's when when you get everyone all siloed and stuff, that's when unintentional mistakes in particular can really creep in. So that's why it's important to have a coordinator. But yeah, if you're looking at sort of if you've had problems previously, I suppose, with trying to think of a word that isn't coordination here, but lacking oversight perhaps in your retrofit process, that might be a nice one to look at as well. Okay, the STBA. So if you've got older stock or your local authority particularly looking at private tenure retrofit in conservation areas, STBA might be the organisation for you. It might be of particular interests at the Sustainable Traditional Buildings Alliance. We're set up with funding, in order to understand what the issues are with doing retrofit on traditional buildings. So they do a lot of stuff around heritage buildings that are particularly vulnerable, and a lot of you'll get, if you ever read any of their stuff, you'll get very familiar with lime mortar. They love a bit of lime mortar at the STBA, and understanding how traditional solid wall buildings and vernacular architecture was designed to function as a building, and therefore when we need to retrofit them for to achieve a greater degree of energy efficiency and have modern heating systems installed, how to do that without destroying the fabric of the building itself, which is a particular concern when it comes to things like damp, mold, and all those related issues. That's particularly where the challenges lie from a technical perspective with those buildings. There's a whole bunch of planning issues as well. And I think as well as other organisations have also published material on retrofitting older homes. If that's a challenge that you know you'll be facing, it's a Historic England, I think, have also got a couple of little bits out there on that as well. And we also do at Rise have particular masterclasses and resources on our website around that topic and planning concerns as well, if that's something you're interested in. And then lastly as well, somewhere else to sort of keep an eye out for that kind of expert insight and advice, the UK Centre for Moisture and Buildings based at UCL do have a lot of detailed scientific research into how moisture moves through buildings, both retrofit and new build, and looking at how we can better assess and monitor that and produce better outputs. So yeah, those sort of programs, just case studies, I guess, just a collection of places that you might want to follow up on to get that better, more detailed insight into specific problems that you might face with your stock, or just to make sure that you haven't missed anything super obvious. There's other places as well that you could go to, and I welcome people suggesting things in the chat on that, the resources they found particularly useful. But I think as a collection, there's enough there to kind of get people started. So hopefully now we've got some ideas on how to identify some of those common risk areas. How do we look to mitigate them? Of course, many of the organizations and well-publicized cases have their learnings published, so you can definitely go away, look at them, incorporate those principles. But what about on an individual property level as well? So looking at that kind of 4-stage risk assessment type of process, beginning with an assessment of a property, what are some of the things that can go wrong with that, and how can you mitigate them? So having things like the wrong assessor, or an assessor that's not knowledgeable enough dealing with particular stock, that can be a particular problem, because, and I know this because I used to work at Cardiff Council, and we'd have to brief some of our EPC assessors, for example, specifically on specific stock types that we had, so that the information we got back from them was actually useful, and not sort of some garbled mess, which is a particular problem on EPCs, admittedly. But as a principle, making sure that the person assessing the property has actually got some idea of what it's supposed to be, particularly if it's traditional or non traditional solid wall or system build type stock. So you can sort of mitigate some of this with training and certification, of course. But yeah, that's definitely one to keep an eye on, I think, from the earliest, because anything, if you put, it's a bit like garbage in, garbage out sort of thing. If you get crap data in at the start, all of the decisions you then make will be flawed inherently, and we normally that only becomes apparent halfway through, and in some cases apparent very late on, when there is very little time left in a grant funded program to do anything about it. Other things as well, kind of related to that inaccurate assessment, so that could be anything in the dimensions, or the construction, or the services in a building as well. And yeah, that's quite obvious. So again, much like the wrong assessor type of stuff, making sure that you've got that, the correct person there with the correct certification scheme, QA checks, and the correct software that cross checks, measures, and costs, and that you're looking at if it says triage assessment on there as well as a mitigation. So as long as you're looking at the building, deciding, okay, that's a particular type of building, we're going to have to get a particular specialist in on that kind of thing. That those are some of the ways in which you can kind of reduce the risk of those wrong assessor and inaccurate assessment types of issues. Yeah, and optimistic fuel cost savings as well. I think really understanding how a occupant actually uses a building is probably the best way to do that, and that should be part of the PAS 2035 process. So understanding lifestyle and how affordable things are to certain people, so how much they might be willing to use the heating, that kind of thing. And other in-use factors for a property that can help sense check some of those things. generally, unless you're operating with real gathered fuel cost saving data, in terms of you have an understanding of exactly how much somebody spends in a property and they've been in there for a few years, I always treat those figures with a healthy degree of skepticism, and certainly wouldn't be using them to inform residents about things as well, because there's nothing worse than promising somebody £300 fuel saving and they only get 40 quid at best or something, or worse, entirely negative because they're using the new heat pump that you put in wrong or something. So we don't want to get into those issues. In terms of the design risk, then there's a number of risks here that can come into play. So things like poor retrofit strategy. So when something isn't fabric first, which is principle, not dogma, by the way. Having inappropriate services installed, no or poor ventilation strategy, poor moisture risk management, and over reliance on technology or complicated systems and controls that people are just not equipped to use effectively, or don't have the time or inclination to learn how to use effectively as well. You could have poor integration of measures as well. So there might be discontinuous insulation or discontinuous air barriers. So things that sort of leaving cold spots on a building, that kind of thing, not adequately enveloping a building, or matching of services with fabric as well. So maybe installing a heat pump, but your fabric of the building is still quite leaky, and not really best suited for a heat pump at that time. Overheating as well, so inadequate shading and ventilation. There are certain properties will be at more risk of that, obviously. So if you've got particularly large, the classic example is high-rise flat with no cross ventilation through the flat, and it's south facing, has a lot of glazing. The thermal gain on that property in the middle of summer is going to be quite disgusting. So maybe when you're thinking about putting that EWI onto that high-rise block, maybe let's have a think about having some shaders and stuff to reduce the intensity of the sun when it's at its highest point, to reduce the thermal gain of the flat and therefore reduce or lower the risk of overheating, for example. And poor communication as well. So just residents who are not engaged, and they're not really understanding or aware of what the intent of your design is as well. So quite a number of ways that we can mitigate these, with the fabric first approach. So thinking carefully about how measures interact and in what order you should do them to get the best benefit to the occupant of that property. Seasonal changes as well. So just talked there about high-rise flat with high level of thermal or solar gain in the summer in particular. How might you be able to mitigate that when it was really, really hot, 40-degree summer a couple of years ago? I think there are probably a lot of people, even some people I work with, who are working from home and regretting that choice on some of those hot days. So definitely something to consider, because it might not seem like it now in February, but things will change. And then some of the things around services that we can do. So having a proper ventilation strategy and considering sort of supply of fresh air, extract of old air, and heat recovery as well, to make sure that you're continuously refreshing the air in that building. And then of course clear communications and a proper resident engagement strategy, both clear communication, not just obviously with your residents, but also the installers as well, so that they know what you expect of them and what the residents expect of them, and that everyone's kind of working in harmony. Installers have the being that they're probably even more than those resident engagement staff that you might have, probably the sort of the first line of contact that people will have with you and your scheme. So making sure that your installers are just briefed on particular resident circumstances and stuff, and are really able to work with them and their unique needs as well, because there's nothing worse than losing a resident's engagement in a project simply because you had an installer that wasn't briefed on somebody's particular needs, or maybe they were just careless and left lots of materials lying around, and a bit of a dirty site, and somebody's kids are running around, and it's very easy to create negativity and a lack of engagement through those ways as well. So being clear with installers as well about what you expect and what the residents need from them as well, to make the process as smooth as possible. And then installation. So when it actually comes to installing these things, obviously, or integration, having lots of different installers come at different times, and people not really understanding who's working on what and why they've left something like that. So that lack of coordination again. And one of the ways, of course, you can sort of mitigate some of that is having multi-skilled teams and more people, or the retrofit coordinator overseeing things properly, and ensuring that there isn't or there is much less of a risk of those problems on site. Inappropriate substitution of materials and products. So design might have specified one thing, and sometimes if a supplier can't get hold of something, maybe there is an appropriate substitute for a particular insulation board or something, as long as it meets the spec. But that's the crucial thing. It's got to meet the the design specification. And I'm aware of one case on a Web 2.1 project, for example, where somebody had not specified, or there was a substitute or something like that for insulation board that was this thick, that was to go on the external face of a wall, and actually they needed something that was about this thin instead, because otherwise you couldn't get wheelie bins down the side of the house, or push chairs, or wheelchairs, that kind of thing. And so then it had a real impact on the people using those properties, and it wasn't appropriate. So there are times when certain materials, yes, you can substitute, but you have to have someone double checking that, I think, to make sure that what you're doing is not going to have an unintended technical consequence on the fabric of the building and the integrity of the design, but also on the way that people use that building as well. So poor installer design, I think that's quite obvious why that might be a bit of a risk around, having for location of services and controls in weird locations, too high. For example, if you have a thermostat that's quite high on the wall, but you've got somebody in a wheelchair using that property, that's going to be a right pain in the backside for them to use. So it's that kind of thoughtlessness sort of thing as well. Ventilation ductwork as well. Seen some slightly questionable examples of this, on sort of QAs before that we've done, where you'll see ductwork with a lot of bends in it and stuff, and every 90-degree bend or something you put in ductwork, kind of rapidly, I think it adds several meters worth of effectively to the length of the pipe work. So you need a much more powerful fan to draw air through, those kind of things. So and the way that you sort of you should be sort of mitigating some of that is of course through detailed design of services, and having services commissioned together, so not separately, so everything's kind of working in harmony, proper snagging processes, and ideally some sort of design oversight. There's a number of ways you can do that, from having separate designers and installers, although depending on your supply chain that might be more or less difficult to achieve. Certainly having some separation, so that the person installing basically is not marking their own homework. I think that's kind of the most important principle here. And then lastly, the operation. So operational consequences. So some of those problems that we talked about right at the start around condensation and mold, controls not being used correctly, systems being disabled or overridden, and performance gap, poor energy performance. And the way you would sort of be able to mitigate some of these things, possibly having a proper handover procedure. So both verbally and graphically, pictures, diagrams, talking somebody through a system, showing them how to use it, getting them to use it in front of you, explaining properly what happens if you disable certain systems, turn the heating off, what that's likely to do to the property, the long term, or the ventilation stuff in particular, particularly if it's a very active centralized ventilation system. People don't like the buzzing from the loft or something. And sampling your post retrofit testing. So have a sample of do some airtightness tests, maybe some thermography, to just get the thermal camera out, try and spot any cold spots, those sorts of things. Some way to kind of understand that, okay, this is performing properly or this isn't. If it isn't, why is it not? Is it a technical problem with the install, or is it somebody not knowing how to use something in that property? But either way, you can then pick up on that early before, a year later, it turns out that the entire, suspended floor has like dry rot underneath it or something, and you need to rip the entire floor out. We want to nip these things in the bud before they get to that kind of disaster point, because that's a lot more expensive and a lot more damaging from a resident relation perspective as well. And yeah, promoting appropriate behavior as well. So, making sure that your RLOs, TLOs, whatever you want to call them, are able to, offer energy efficiency advice and how to mitigate things like overheating or lifestyle changes to suit the retrofit. Obviously, we should be retrofitting with the people in the property in mind, so that there are decisions you can make at design stage which accommodate that. But there will be, possibly elements of behavior change required as well, particularly around heating systems and ventilation systems, to ensure that things are running smoothly. So risk management then in PAS 2035, because much of what I just said is sort of covered by PAS 2035 in one form or another. So just to flag what some of these things are. So in the paper on the right on there, the moisture in buildings, an integrated approach to risk assessment and guidance, that standard really fed into the development of PAS 2035 and introduces the 4 Cs. So when you are approaching retrofit and thinking about the impact of moisture in that building, these things should be considered. So context, coherence, capacity, and caution. So, the geographic context, is it west coast of the UK, is it east coast, different levels of moisture, for example, in that case. Legal, so there might be planning issues impacting what you can do, and cultural as well. So, some people from certain backgrounds might, cook differently, for example, or cook in certain ways which generate more moisture into the house. Thinking about that. Coherence, so having a consistent approach to thermal, moisture, ventilation, and internal air quality issues, taking those seriously and having processes in place to deal with them. Capacity as well, so sizing for ABIS as well. So, not theoretical conditions as the building, is built and in service, how it's actually used. And don't over optimize as well, because people themselves, unless they're a massive retrofit nerd, are probably not going to want to optimize their heating system to run, efficiently to the nth degree. People don't really tend to go for that. So yeah, don't over optimize your systems. Leave a bit of wiggle room in there for them, just to give you that peace of mind, that safety. And then yeah, caution on there. There's a lot that we don't know. So yeah, identify, assess, and mitigate those risks where you can, and avoid taking unevaluated risks as well. So those 4 Cs around managing some of those, sort of moisture risks, that's how they kind of feed into PAS 2035. And this is that tool that I referenced earlier when we were looking at the GLA Renew matrix. This is kind of a very similar one from PAS 2035, and it's got that matrix of measures to help you understand, the designer understand, where certain measures interact, what is the level of risk between those measures, and where there is a high level of risk, that might be for a number of reasons, but that might be the time where it's good to have a look at those 4 Cs and think about what some of those risks might be and how you can mitigate some of them as well at the design stage, when you're going forward. So just got a little over 15 minutes left, so I'm going to try and whiz through this last section on resident engagement, and then we can open up the floor to discussion, because I'm sure people have plenty of examples they can talk about relating to those things. So yeah, the final crucial area, resident engagement, because people live in these houses that we're trying to retrofit, and that does impact them quite significantly. So I think Well, I'll talk about these. I think this resident engagement sort of issue. I think from the perspective of an air source heat pump installation, because I think that's quite a good example to work through because it touches upon kind of lots of important nuances in regards to residents' acceptance and usage of retrofitted energy efficiency products. But the key principles can be kind of applied to any new retrofit measures, including fabric works, but usually things with like an active to a passive measure like wall insulation will kind of have the most issues, or there's more opportunities for it to go wrong with resident engagement. So we'll go through each of the four kind of key benefits on the slide now. So those areas around improved understanding and acceptance, enhanced user experience, feedback loop, and compliance and safety, and why if you get your resident engagement right, those four benefits really come through. So the first one, improving understanding and acceptance. So if you are able to engage residents early in the project life cycle, that's regarded as pretty essential for the successful adoption of heat pump technology. So education and awareness playing a critical role in gaining resident buy-in and cooperation, because they just have more time to take on board information, become comfortable or at least accepting of it. If you spring things out of the blue, people are a bit kind of taken by surprise, taken by ambush. If you lay the groundwork and plant some seeds early on and kind of warm people up to the idea, generally that as with a lot of things in life, that tends to kind of go down better in the long term and help you achieve those objectives. So yeah, you get those reduced rates of resistance, better cooperation, and higher acceptance rates as well. So engaging early helps you get those things. The enhanced user experience as well. So we really want to try and ensure that people are using things properly, minimize the risk of them, messing something up, and leaving them with very satisfied experiences. So we want to give clear instructions and training. So we want detailed user manuals. So we want them to be, so the information is there if they are the type of person that will read the manual to do things. Then it should be available for them. It's a relatively low effort way to get all the information out there, but by no means the only way that you should be doing that. I think one of the other things you can do for that, I think, is you can, I've seen examples where people will have like QR codes on things to link to online copies of instructions, or or like how-to videos to kind of troubleshoot common problems with systems, which is really nice, because unless you're a very organized person, there's when you need that manual to look up an error code on your boiler, for example, it can help avoid that kind of mad scramble trying to find where the boiler manual was. Could never be enough having a folder in my house with all that kind of stuff in, but not everyone is as sad as me. So some people will really benefit from having that kind of available instant digital access to things. Training sessions as well, so being able to organize training sessions or workshops or some way of engaging people together to demonstrate the correct usage. And I think sometimes as well that can be quite nice, because you maybe get people feeling like that's a silly question, I shouldn't ask it, but if you can get one person answering it or asking it, then kind of people think, oh, it's not just me that was wondering that, and they kind of open up a little bit and maybe are a bit more forthcoming if they're not sure about something or how to use it. Talked about online resources already, videos and FAQs, that kind of thing. Having ongoing support as well, so customer support hotline, particularly I think in the period of time following a recent installation, having that dedicated project hotline available for a period of time afterwards to support them with any kind of questions, issues, snagging type of things, because that's normally when those kind of problems will crop up. It's in the months following, and installers, people are kind of still settling in and getting used to things. And then offering on-site assistance as well for troubleshooting and maintenance when needed. So normally I would imagine your RLOs would probably be more familiar with where the like, the expected problem properties might be in terms of people who are more likely to need support with things as they go. So being able to offer them that support, important. And then, yeah, regular check-ins as well. So maybe like a few months down the line, have somebody check in with them and say, are you still comfortable using that heat pump? Have you got any problems or questions? That kind of thing. And then lastly on here, I had on my sort of big list of things, user-friendly design. So having intuitive controls, mobile app integration to control, the heat pump remotely or something, and a feedback mechanism as well, so they can tell you what's working, what's not, suggestions for improvement. The intuitive controls thing, I think, is really big as well. Speaking to a guy from 13 Housing in the Northeast who's quite big on the intuitive control thing. And just, I think they've installed like 800 heat pumps or something now. They've been quite big on it the last few years, and in their experience, they were really finding that giving dumb controls to people was the best way of, that they would set it all up efficiently for the property and then almost put it like a little plastic cover over it, something screwed in, like, do not touch this. Here's your dial. If you want more hot, turn it that way. You want more cold, turn it that way, and that way then it gives people that feeling of control over their heating system, but it gives them the control within parameters which won't fundamentally break the efficiency of the system, I suppose. So I thought that was just a really good example there of, managing people who will possibly be quite used to using, like, combi boilers or something like that for their heating, and getting them to not break the new heat pumps. Feedback loop and increased satisfaction. So having that feedback mechanism, suggestion boxes, focus groups, collecting that data so you can then improve on things next time, and also identify any issues early as well and resolve them. So you could implement monitoring systems to detect and report issues early, or particularly early on, schedule more regular maintenance checks based on feedback to address potential problems before they escalate, and letting things settle in. Then, ensuring that you've got that quick response to any reported issues, providing that timely solution, again, particularly early on in the months or year following a project where, again, you're most likely to see that first wave of problems crop up, as well as that first heating season, for example. So compliance and safety. So again, the benefit of doing all of these things, of course, then is to minimize the risk and improve overall safety for your project there. So a few ideas on this slide. So training resident liaison officers for outreach and support, particularly for heat pumps, for example. If you've got the heat pump scheme, making sure they know the principle of a heat pump, how those systems in those homes are supposed to work, so they can offer that kind of first stage of advice to people. Offering residents an annual energy check-in appointment, for example. So if you've got those that go out and visit homes, as well, it's something you could kind of tie in with other aspects, home visits as well, to people to check in on, for other issues as well. But as part of that kind of thing, there might be a way to get some energy checkup type thing in there, and it gives you that chance to get a bit of feedback from people as well. And also, sort of look at the, maybe the ways in which, like, the energy efficiency side of things sort of links in with some of those wider issues as well around health and well-being. And then, making sure to plan and budget for all this as well. So you budget that, that kind of stuff into your project, and following up with the resident after. And hopefully then all that effort pays off and you get to enjoy some lovely feedback, such as this feedback that we've seen from people in Gloucestershire and Lincolnshire as well. Where it's just really nice to see that if you handle it well, you do a good job, and people are supported. This is the best and cheapest heating system I've ever experienced. It's a blessing in disguise. We feel really lucky. So if you get it right, it really does have very material improvements on people's lives, and they can really benefit. But we also do have a lot of on-demand resources as well there on the screen now, if you're interested, around things like engaging tenants with heating technology, building your business case, a project plan, and then also some of those podcasts and things as well. Thank you very much.